بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 1.2 about functions. We start by relations and functions. A relation is defined by set of ordered pairs of real numbers. So a relation is just a set of ordered pairs. For example, the solutions to this equation, this is an equation, the solutions of this equation are pairs of numbers, value for x and value for y. So in fact, this equation expresses a relation between x and y. X here is the x value, the first number is the x value, and the second number in the ordered pair is the y value. So a relation is defined to be just set of ordered pairs. For example, this is an example of a relation. Okay, set of ordered pairs, this is a relation. Now, set of the first components, the first component of the relation, okay, 1, 2, 3, 4, this is called the domain of the relation. And the set of the second components, 3, 6, 9, 12, is called the range of the relation. We can express the relation like this: the domain 1, 2, 3, 4, the range 3, 6, 9, 12. The first ordered pair, for example, is taking 1 to 3. The second ordered pair is taking 1 to 6. The third ordered pair is taking 2 to 6, and so on. So, for example, from this figure, we know that there is a relation 1 to 7 and 2 to 9 and 3 to 11 and 4 to 11. So this figure represents this relation. Now, what the relation would be a function. So the functions are special relations. What happens? Each input x results in exactly one output y. So for example, here, this relation is not a function. This relation is a function, sorry. This relation is a function because each input results in one output. So the output of 1 is 7. It's only 1. The output of 2 is 9. The output of 3 is 11 and only 11. The output of 4 is 11. So this is a function because each input results in exactly one output. Each element of the domain or the input, there is correspondingly exactly one element of the range, the output. This is the function. But here, for example, this relation is not a function. Why? Because the input 1, for example, we have 1 as an input, but the outputs for 1 are 2, 3, and 6. Also 3 in one input and has 2 outputs. So this is not a function, while here it's a function. So in fact, we cannot accept that 2 arrows go from one element in the domain. But all of the arrows could go to the same element here. It is not a problem. So each element in the output could go to one, in the input could go to one and exactly one element of the output. then it would be a function. The domain or the input, the variable that represents the domain or the input, which is usually x, is called the independent variable. And the variable that represents the numbers in the range or the output is called the dependent variable. So for example, in this equation, x is the independent variable. It's also the values of x will give you the domain, and y is the dependent variable, and the values of y will give you the range. Example, does this equation expresses y as a function of x? And the answer is no, because if you choose, for example, x to be 2, so this is one value of the input. If x is 2, then y square would be 2 times 2, which is 4. And if you solve this equation for y, y would be plus or minus square root of 4, which is 2. So 2 is the input, and it goes to 2 outputs. So this is not a function. This is not a function. It's a relation, but it is not a function. We can graph the function by graphing the ordered pairs that represent the function. Okay, so always the first value, we will put it along the x-axis, and the y value along the y-axis. So this is called a rectangular coordinate system. A rectangular coordinate system. We draw two lines, two perpendicular lines. This represents the x-axis, and this represents the y-axis. Now, each point is associated with an ordered pair. Okay, so the point has ordered pair, and this ordered pair is called rectangular or Cartesian coordinates. Cartesian coordinates. So the x coordinate is the first value, and the y coordinate is the second value of the ordered pair. The graph would be graphing all the ordered pairs. We plot all of them. So here, for example, this ordered pair 5 and 2 is associated with this point. 5 is the x value, so x here is 5, and y is 2. So to find the x value, you draw a perpendicular line to the x-axis. So for the point B, the value of x is -4, and the value of y is 1, and so on. How to graph a function? We use the point plotting method. We choose points. Okay, so we make a table of coordinates, and we choose as many points as we need to sketch the graph. So for example, I can choose from -2 to 2, or even more than that, from -3 to 3, from -5 to 5, as you wish, until you understand the graph, until you figure the graph of this function. So if you replace x by -2, -2 square would be 4 times 3, y would be 12. If you replace x by -1, -1 square is 1 times 3 is 3. If you put x 0, y would be 0, 1, 3. If you put x 2 square times 3 is just 12. And now you can plot all of these points here on the xy coordinate system. So at -1, it is y. When x is -1, y is 3. When x is 0, y is 0. When x is 1, y is 3. And you can notice when x is -2, y is 12. And when x is 2, y is also 12. So you can just try to connect now these points, and this will give you the graph of this equation. We call this graph a parabola. Okay, this is called a parabola. So this is the graph of y equals 3x squared. 3x squared. We can find out using the vertical line test that the graph represents a graph of a function or not. If each vertical line, or if no vertical line intersects the graph at more than 1 point, then the graph is a graph of a function. So you have this graph, for example, you draw vertical lines, vertical lines. If each vertical lines intersect the graph in no more than 1 point, only 1 point, only 1 point, so it would be a graph of a function. So this is a graph of a function. This is y equals 3x squared. While y squared equals 2x is not a graph of a function because this vertical line, for example, intersects the graph in 2 points. So this is not good. It means that 2 in the domain goes to 2 and -2. So one input has two outputs, so this is not a function. While here each input has only one output. Function notation, we will write always y equals f of x. So y is the function of x. Y is a function of x. We read it f of x. Okay. We can write it like this. This is, for example, a definition of one function. We can use this definition to find f of 2, for example, the value of f at 2. When we write f of 2, we mean x is 2. So we replace x here by 2, and we can find the y value when x is 2. So 2 is in the domain and 5 is in the range of this function. And this is the point, for example, 2 and f of 2, or 2 and 5. So x is 2 and y is 5. And 0, 0 and f of 0. F of 0 would be -3. If you replace x by 0, y would be -3. So this point represents 0 and -3. And this is the point -4 and f of -4, which is -7, and so on. We can call the function g or h. It's not necessarily f. We use f, g, or h, or also maybe we can use other letters, but these are the most famous. This is an example. This is a definition of a function. Find f of 3. So to find f of 3, we just replace x by 3. So it would be 2 times 3 to the power 3 minus 3 times 2 to the power 2 plus 1, and we just use the calculator and find the answer. So it would be 2 times 27 minus 3 times 4, because 2 square is 4, plus 1, so it would be 43. So f of 3 is 43. F of -1, we replace x by -1 and evaluate and find the answer. So this is -2, because -1 to the power 3 is -1, minus 3 because -1 to the power 2 is 1, plus 1, so the answer is -4. F of -a would be 2 times -a to the power 3 minus 3 times -a to the power 2 plus 1. Notice that always I put parentheses because I have -a. Okay, so this would be 2 times, now -a to the power 3, -1 to the power 3 is -1, and a to the power 3, minus 3 times negative. Now negative 1 to the power 2 is just positive, so I will have a square plus 1. So now I have negative 2a cube minus 3a squared plus 1, and this would be f of negative a, domain and the range. Well, uh, we will always talk here about uh, real functions, functions whose domains are real numbers, or subsets of real numbers. The domain will be always consists of the inputs, all the x values. Okay, the x values, all the x values or the real inputs, and the y values or the outputs would consist the range of the function. So to find the domain, look to the x values. To find the range, look to the y values. uh, the domain would be always a set of all real numbers, except if you find that you have a square root. Whenever you have a square root, so the numbers inside the square root should be always positive, because the square root of negative 1 or negative 2 is not real, is not a real number. So any number be inside the square root should be always positive. You cannot accept that the number is negative. So for example, if he asks me to find the domain of this function, I will ask that 4 minus x must be positive. So when I solve this inequality, negative x would be greater than or equal to 4, then x would be less than or equal to 4. So this is 4 and this is less than or equal to 4. So the domain would be from negative infinity to 4 closed, because I have equality. So this would be the domain of this function. If you choose any number here for x, I will have positive numbers inside the square root. While here, when I have a denominator, we cannot accept that the denominator is 0, because 1 over 0 is not a real number. It's not defined. It's a math error if you put it in the calculator. So x here cannot be 2, and the domain of this function would be all real numbers except 2, because 2 will make the denominator 0. Or we can write it from negative infinity to 2 union from 2 to infinity. So it's all real numbers except 2. So 2 is open, and we have from negative infinity to 2 union from 2 to infinity. While in A, I have no square root, no denominator, so the domain here would be from negative infinity to infinity, or just all real numbers. Now this is a checkpoint. If y equals f of x, the independent variable is x and the dependent variable is y. 1, 3 is on the graph of this function. So what would be f of 1? F of 1 would be 3, the y value. If f of x equals this is a function. What is f of negative 2? F of negative 2 would be 1 minus negative 2 to the power 3. So it would be 1 minus negative 8. So it would be 1 plus 8, which is 9. Find f of x plus h. Well, f of x plus h would be 2 times x plus h to the power 2. So we just replace x by x plus h. Now, to simply to expand this, uh, I have x squared. I raise the first term to the power 2, then plus 2 times the first term times the x term, the second term, then plus h squared. This is how we square a binomial. This is f of x. What is the domain of f of x? We have a denominator, so the domain would be all real numbers except the number that makes the denominator 0, which is negative 1. So this is the domain, or we can write it from negative infinity to negative 1 union from negative 1 to infinity. Operations with functions. We can define sum of two functions like this: f plus g of x equals f of x plus g of x. Also difference, also product or multiplication, and also division. But here notice we cannot accept that g of x is 0, so g of x shouldn't be 0. The domain of these functions, these new functions, sum and difference and product, would be all real numbers in the intersection of f and g. So the domain of f plus g equals to the domain of f minus g equals to the domain of f times g equals domain of f intersection domain g, while the domain of f over g, okay, would be the domain of f intersection domain g minus zeros of g of x. So we have to remove the zeros of g of x. G shouldn't be 0 because it is in the denominator. Well, this is an example. F plus g would be f of x plus g of x. So it would be 3x plus 2 plus x squared minus 3. So it's x squared plus 3x. 2 minus 3 is negative 1. Also, you can find f of minus g of x by subtracting the two functions. So it's 3x plus 2 minus x squared minus 3, or 3x plus 2 minus x squared, and then minus times minus is plus 3. So the answer would be negative x squared plus 3x plus 2 plus 3 is just 5. F times g, f of x times g of x. So it's 3x plus 2 times x squared minus 3. And now you expand 3x times x squared is 3x cubed minus 3x times 3, that's 9x, plus 2 times x squared, and 2 times negative 3 is negative 6. So you can write it in a standard form in order like this: minus 9x minus 6. F over g would be f of x over g of x, and this would be 3x plus 2 over x squared minus 3. This is f over g of x. Notice here the domain of f is the set of all real numbers, and the domain of g is also all real numbers, because we don't have a denominator and we don't have a root, a square root. So the domain of f plus g would be equal to the domain of f minus g, the domain of f times g, which is from negative infinity to infinity, because that's the domain of f intersection domain g, while the domain of f uh, over g would be all real numbers, which is the domain of f intersection domain g, minus the zeros of the denominator. And the zeros of the denominator is plus or minus square root of 3. Because if you put x squared minus 3 equals to 0, you have x squared equals to 3, which means that x is a plus or minus square root of 3. We can write it like this: from negative infinity to negative square root of 3, union from negative square root of 3 to square root of 3, union from square root of 3 to infinity, because it consists of all real numbers except negative square root of 3 and square root of 3. So this would be in the domain, this would be in the domain, and this would be also in the domain. The last operation is the composite function, f circle g or G circle f of x. This is the definition. F circle G of x is f of G of x, and G circle f of x is G of f of x. The domain of G circle f would be equal to the domain of f intersection the domain of the result, where the result is your answer. This is an example. F and G. What is G circle F? By definition, it is G of f of x. And now how to evaluate this? We put f of x first. We write G as it is, and we put f of x, which is 2x cubed plus 1. And now we find G of this. How do we find G of this? We go to the definition of G and replace x by 2x cubed plus 1. So I will have 2x cubed plus 1 raised to the power 2. And I can expand this, the first term squared plus 2 times 2x cubed times 1. This would be 4x cubed plus the square of the second term, which is 1. While f circle g of x would be f of g of x. So it would be f of g of x now as x squared. F of x squared, I go to f, replace x by x squared. So it would be 2x squared raised to the power 3 plus 1. So it would be 2 times x to the power 2 times 3, which is 6 plus 1. This is a figure for G circle F, for example. X goes in the domain of F. Then I have f of x. Then I put it in the domain in G. I get G of f of x. Also here, F circle G. X goes in the domain of G first. Then the output will go in the domain of F. Then I have F circle G, which is 2x to the power 6 plus 1. Checkpoint G minus F would be G of x minus f of x. Please continue. Also, f times g would be f of x times g of x. F circle G would be f of g of x. It would be f of g of x is 3x squared. So now how to find f of 3x squared? I go to f of x, replace x by 3x squared. So I have 1 minus 2 times x, but x is replaced by 3x squared. So the answer is 1 minus 2 times 3, 6x squared. This is f circle G. Please try to find G circle f of x. Let us find f circle f of x. It is f of x. Well, f of x is 1 minus 2x. And now to find f of this, I use again the same definition, 1 minus 2, but I replace x with 1 minus 2x. So it would be 1 minus 2 times 1 plus minus 2 times minus 2 is 4x. 1 minus 2 is negative 1 plus 4x. So this is f circle f of x. This is the end of this section. Thank you very much and have a nice time.